let's start talking about Splunk. So we're going to talk about the first 4 modules today, and the rest will be in later classes. So introducing Splunk. Splunk is Google for log data. That's the simplest and best explanation of what it is. So we're going to talk about it. So you have all these devices on your network. You have servers and firewalls and email servers and all different things, and they all register logs. And in the old days, the logs would be on that machine. So if you had to investigate a security incident, you'd have to go to each machine to see the logs. Yeah.
Is this connected to the site, this deck,
So the site
this
that
presentation?
this is on my website.
Great, I just
Yeah,
want to be sure.
yeah,
that
no, that's good. And you'll find it in
accessible.
the course materials here, right there are the
Got it.
slides.
Cool.
Yep, very good. Yeah, that's important. All right. So anyway, what this does is it forwards the data all to a central server. Every device sends its log data over the network to a central server, and then the central server you can index it and search it there. Yeah.
And that data that's sent to that central server, that's set up through some sort of a chronological job that you assign,
Yes.
and that's written by the network administrator somehow.
Well, you don't have to write it yourself because it turns out Splunk provides agents for most common things, and everybody that makes anything, every firewall manufacturer, they write a Splunk module for their product because nobody would want to buy it otherwise. And if you have some weird off-brand thing that doesn't provide a Splunk module, there's a whole community of people, and one of them will write a module and put it in open source. So
It's sort of like
yeah.
autosave in Google Docs. It just
Yeah.
sort of does it for you.
That's right.
Okay.
And you could, in principle, write your own, but in fact, unless you have some bizarre device, somebody has already written the Splunk forwarder for it. Yeah.
Is there a general sort of best practice for an interval for that cron job to run? Is it every 24 hours, every 12 hours? Every
Oh,
6?
much sooner than that.
Okay.
You basically want it to be continuous.
Really?
You-
So
oh,
like every minute?
Yes, you want it to just send logs in very frequently because you want it to be up to date because you might detect something, you might want to respond right away. So back maybe 20 years ago, you might get it every day. Now people expect it to be essentially real time.
So how much resource is an individual machine using to send that every minute?
Well, it can be a lot. That's an issue. I mean, depending on what you've got, for example, Windows logs are really big, especially if you turn on optional logging, which you probably want to. That's why a lot of servers, like database servers, they have very rudimentary logs because it does slow down performance to log more.
But if you have like a massive network where you have mobile devices and,
Yeah.
and other servers all sending it, so then it
Yeah.
must put a load not only on the individual machines but the central server receiving all the logs.
It does, and that's why the companies don't really balk at paying $10,000 a month for Splunk because they're going to have to pay a lot more than that for a whole bunch of servers and storage units just to handle all that log data. And that's why even having like 500 gigabytes a week of log data is probably not enough. You're going to have to buy more. If you have a big network, you have a lot of log data, and you want to archive it all in one place and search it all in one place. It's the only way you'll ever be able to make progress figuring out attacks on that big network.
And so then, when you're talking about that big network, are we
Yeah.
talking about leasing space from a company like Amazon on
Yeah.
AWS?
Typically, yeah.
Okay.
I mean, you
Not
could,
necessarily. I mean, obviously, Google and Amazon build their own server farms. They have data
Right.
centers. Blah blah blah.
right. Most people just rent it from one of the cloud
Right.
services,
Yeah.
but you could have your own data center and set up your own servers too.
And theoretically, since you said one place,
Yeah.
are you physically thinking of that as one place, or are you allowing Google or Amazon to redistribute across their data centers and
Oh.
assume they are backing up redundancies?
Well, you typically, well, that's actually a difficult question. For a normal company, you would just let them put it wherever they want. But if you're
Physically, you want
yeah,
to
yeah,
be
like
clear,
all
it's
you care
living on
about,
a block somewhere in
Yeah.
like Oregon or something.
yeah, and if you're using Azure, for example, they won't even tell you what country it's in,
Yeah.
and you won't even know. But if you are a critical infrastructure company or the government or the military, that is not acceptable. So you pay a higher price for them to guarantee it'll be in the U.S. And you might pay them to back it up, and if you're really careful, you might make your own backup outside their system, because sometimes their whole system goes down.
In what, like a network attached storage at home or
You
something like that?
no, most people do multi-cloud.
Okay,
most people
so you
don't-
would have a deal with AWS, and then you would also go to Google.
Yes, or Azure. This is what most companies are now multi-cloud companies for this reason, because all the clouds have their limitations and problems. And by the way, this leads to a lot of security problems. Because everybody's doing multi-cloud, you have to have authentication at all these services, and keeping them all organized is difficult. So there's usually a bunch of abandoned accounts that still work, and accounts that are administrator accounts that shouldn't be, and all that. This is a huge problem keeping it organized at that scale, but most people are doing multi-cloud, and they're mostly not doing a very good job of it. Yeah.
So sorry, you mentioned,
Yeah.
deprecated accounts that don't get taken care of.
Yeah.
Does Splunk or companies using Splunk, have they engineered a way to like go through and remove, let's say there's a layoff, right? A regular
Yeah.
layoff.
Yeah. As far as I
And
know,
they need to deny access.
I don't think Splunk has that, but supposedly things like Active Directory do, and Amazon does.
Sure.
And if you take there's Amazon certification classes here, there are tools just to hunt for orphan databases and orphan accounts. But this is kind of in its infancy. Like I say, most companies, even huge companies you would trust, have a huge problem with this. In my machine learning course, I've got some slides about this. The average company has something like 50,000 cloud accounts, and like almost all of them are complete administrators with access to everything, and like half of them have been forgotten and aren't properly secured. It's really madness, and that's why you constantly find breaches saying all this data was just sitting in the cloud publicly available, or the credentials were just sitting somewhere. This keeps happening. It is such a mess that very few people can be organized to really secure it right now. That's why when people started moving to the cloud about 5 years ago, most companies were nervous because they were worried about the security implications, and they were right. It's much trickier to be secure in the cloud. Yeah,
Sorry, I keep asking questions.
that's fine.
Do you think that these risks become exposed because of the speed at which computer technology just works, like, and the way that anyone with the knowledge can get into it, right? Like, if I have a certain knowledge level
Yeah.
and resource access,
Yeah. Well,
namely the internet, I can basically figure out any technology solution I need.
Well, yeah, but that's not the real problem. The problem is Moore's law. The problem is it keeps changing. If it would just stop changing for 10 years, then we would all learn how to secure it. But the reason we're all here, the reason you have to keep taking classes and there's such a boom in technology, is every year they invent a bunch of new stuff. So you can never keep up. If you know everything, they invent new stuff next week. And that's the problem. Even if you have some system of organizing things, then your staff will turn on the new things and do things, and it's hard to keep track of all
And
that.
isn't that also what AI is going to technically exacerbate? Because you can
Yes.
set off some sort of broad AI if we get there, and have it just go off and iterate, and you never
Yeah.
catch up.
That's the issue. Right now, people are trying to make AI defenses to deal with the AI attacks, but everything is in its infancy. Yep, that's right. Like I say, I do corporate consulting for AI security, and you're right on the right target. They promise that AI will protect us, but in the short run, the first thing it does is help the attackers. Always the new stuff that you don't really understand is first exploited by attackers. That's why, like most people, I started in hacking. They're teaching the hacking course down there. I did hacking for a few years, attacking servers, and then I got kind of bored with it because it's kind of all the same, and I got into defense. Defense is much harder than attack. You have to close every door. You have to watch for things coming in. Attack is pretty easy. You just learn a few attacks, and when they work, you're in. In defense, you have to think of everything and close all the doors, and you have to stop all your employees from doing stupid things like installing unauthorized software, unauthorized hardware, putting on old dates, blocking the updates.
Taking the secret iPhone and leaving it at the brewery in Menlo Park.
That's right. Propping the door open so they can go smoke.
Yeah.
It's very hard to stop your staff from doing stupid things that breach your security. And that's why it's not glamorous, and it's not even really all that technical, but defense is really hard. Defense is really a matter of policy and management. And, I ended up there eventually. Anyway, so, all right, this is very good questions. So, the point is you're going to take data from all your gadgets and forward it to one central repository of all that data, and then give you a way to easily search through it to find out what's going on your network. So you have the thing called the Splunk search head, which gives you this Google-like interface, and then it goes to an indexer, and that has all the data that came from all these forwarders that forwarded
These
from
are software modules.
software and hardware. I mean, down here you have things like a firewall, but it's running a software module called a forwarder that sends it up to an indexer, which is a server with a lot of storage, which stores it all. And then you have the search head is another computer, which sends queries in basically SQL down here to search through the stored data. And all of these are, of course, clusters of machines at big companies and geographically distributed.
So physically located in many Theoretically.
in a
this
big
would be
network,
location.
they're just all over the place, just like all your servers are. Yeah. All right, so Splunk Enterprise is what we're going to use. That's the normal one. And there's also Splunk Cloud. This is an option. You can just pay Splunk to give you a cloud service, so they'll set up all the servers, and you just send your data up there, which would be pretty attractive. You don't have to set up your own servers. And there's also a Splunk Lite I've never used. But we're going to use Splunk Enterprise because you can install that on your one machine and practice with it. And that's, of course, what we're going to do because we don't have the resources to set up these multi-machine clouds for this class. So then there are Splunk apps. You can add plugins to Splunk apps. They're just sort of like the plugins you might put in Google Chrome that add extra features. So there's a bunch of ready-made apps, but we're hardly going to use any of these. We're going to use the basic Splunk functionality. We don't really need to get into the apps here, but there are apps for every possible purpose, just like there are iPhone apps for every possible purpose. So there's also enhanced solutions. There's IT intelligence to try to hunt for your data for you, enterprise security, user behavior analytics. These are all advanced features, which we're not going to use any of, but they like you to know. This is sort of the marketing part of the slide. Yeah.
So when you're each of these main bullets, these are sort of subcategory. Are they also their own GUI?
Yeah, these are advanced features you can buy from Splunk.
So they're additional tools.
Right.
What would you liken them to in another software suite?
I don't know. I never learned how to use any of these. I only know the basics because I was a database administrator, and I learned the database part of Splunk, and that's when I was done. I haven't learned any of this stuff or used it. I have to be the big company to do it.
I'm sure that we can Google it.
Oh yeah, and probably it might have changed by now, because these slides are a few years old.
Got it.
These slides are from 2018, back when it was free, so they might even have changed some of these offerings by now.
Okay.
Yeah. Anyway, so users and roles, just like you thought. There's administrators, power users, and limited users available. And of course, the administrator can install Splunk components and delete data and do dangerous things like that. And these lower level users can't do that, of course, just like Windows or any other system. So you log in with a web browser, you have a web page, and you just log in with a username and password, and then you will see where we're going to spend this whole class, here on the search page. This is the main page you're going to see of Splunk. It looks just like Google. You can search and see right here, it has 5 million log events, and you're searching through them here. And you're just typing in a query like what you want to find. And you just learn the right queries to put in to find attacks. That's all we're going to do is learn how to use this. All right, and then they have various apps. This is technically called the search and reporting app. This is what we're going to use. Yeah.
So you log into Splunk using a web browser.
Yeah.
We all know companies like Google run Chrome and so forth. Is there a data concern about what is being shared from the browser when you're looking at Splunk?
Yeah.
Should you be using something like Brave or?
Yeah. The queries you type in will probably be stored locally in the cache and in the RAM, and the results will probably be in there too, because you appear on a website. So the machine you're using will contain the information. And it's also going to be on the server, and it's going to be transmitted to the server. Now, if you properly configured your server with a real HTTPS certificate, then at least it's encrypted. But in fact, most people use a self-signed certificate, which is not that safe. So those are good concerns. Some of the data is on the workstation you're using, and some of it is transmitted, and perhaps not with perfect security, to the server.
What do we do about that? Use Brave.
Well, the best thing is to have a real certificate on the server and to work on a trusted workstation. And what I do, most of my consulting now, I don't use hardware. They give me a virtual machine to use in the cloud. Most companies will give you an Azure cloud machine to use, and you connect with remote desktop protocol. So none of that data is ever on my machine at all.
So they actually have a physical computer that you log into and take control of to then log into their network?
Yeah, it's a virtual computer. It's running on Azure. It's a virtual machine on Microsoft servers, and you remote control it. That's how I do most of my consulting now.
You mean it's more protected than...
What's that?
You mean it's more protected than...
Yes, more protected. The point is then the data never leaves their control. The data goes from their server to their virtual cloud instance desktop, and I'm just viewing it with a viewer.
So theoretically, you could do something similar at home, like if you got a Mac Mini.
You could.
And you leave it at home, and it never leaves your house.
Yep.
And it's protected by the network that you have put this certification on at your house.
That's right. And I have
And
students
then
that do
you
that,
could
yeah.
remotely from anywhere in the world log into it.
Yes, and this is something a lot of people do, especially if they go to like hacking conferences like DEF CON. They remotely connect to their trusted machine instead of taking something that has proprietary data into a dangerous environment like that. Yep, and that's why most companies will not give you a company laptop where you're going to have company data on that laptop anymore, because how do they know it's safe? You might be losing it, you might be carrying it into dangerous places. You connect to a cloud machine, so all the data stays under their control. It goes from their server to their cloud machine, and you never have it. That's much better.
You just have access to.
You have access to it, yeah. You have a username and password, and typically a two-factor token.
So like the picture of like the users. Like
Yeah.
You can do too much with.
That's right. You also have limited access. Yeah, that's what I have everywhere. Like if I want to install anything on that cloud machine, I can only install things from the official company store that only has certain apps available. And if I want anything else, I have to submit a request and they examine it and approve it to make sure I'm not putting dangerous stuff on there. Yeah.
So then the log point at what the user is doing from
Yeah.
Splunk's perspective, if we're talking about a scenario like what you're describing,
Yeah.
only starts when that user logs into that virtual machine.
I would think so, yes. And they probably do have logs of who logged into the virtual machines, because that's a possible point of attack. If somebody could sneak into my house or steal my two-factor token, they could log in as me, and then they'd want to know where they came in from. So they should be logging that.
So they log the IP where the initial request for the login.
They should be, yes. These are very good questions. You're right on the right track. All right. So, all right. And let me check for questions online on Twitch. Nothing new. Okay, good. All right. So, all right. So the home app is the default app you see, and the only thing we care about the home app is you go to the search and reporting, and then you do the search from there. The other stuff we're not going to use in this class. Search and reporting is the main thing. You can then search all that log data. And so here's how it looks. You got a Splunk bar at the top. You got an app navigation bar with some things you can click here. This is the main thing you use, the search bar, where you type in a query like Google. Then you have some information here about the data that's available, how many records they are, how old they are, and so on. Here you choose the time range. By default, it will only search for things within the last 24 hours. And that's normally what you might want on a network. In our case, we're going to be using archived data that is many years old, so we're going to set this to all time. And then you'll see your search history here, and you can see more information about the data there, which we'll do soon. Yeah.
If you were monitoring an actual attack, though, like real time,
Yeah.
you'd be setting that to a very small interval and then probably just refreshing.
Yeah, you
moment to
could.
moment.
And by the way, I wouldn't use Splunk for that. For that, you want an IDS, like Suricata, to respond in real time. They have some real-time features, but in fact, they are very burdensome to the server and pretty slow, and Splunk is kind of clumsy overkill for that job.
So if you were actually so when you're using Splunk sort of professionally, you're using it to post-mortem an attack that you've already dealt with.
Yes. Well,
And
you have some kind of warning, like an alert goes off, like an antivirus alert, and you're investigating to find out what happened.
right.
And so you're typically looking some period in the past. And your immediate response was to somehow try to contain it by isolating that network segment or something. See, there's several steps to instant response. You got a whole class in it.
Well, rollback would be one, right?
No. In fact, people try to roll back, and that's usually a mistake. When you have an incident, like somebody has a warning go off, say your machine is infected, then the first thing you have to do is an immediate appraisal of how big the damage is. You do some quick attempt to find out, is it just that one machine? Have they infected the server? Have they infected all the things in a certain location, or what? You make some attempt to decide how big the problem is.
That's the search I'm gonna do, or.
Well, you might use Splunk for that, but probably not. You'd probably use something much simpler. And then, once you have some idea how big it is, then you isolate the attack. You separate all that stuff from the rest of your network. So some part of your functionality will go down. And then you analyze those machines to figure out what exactly happened to them and develop indicators of compromise so you can scan the rest of your network. And that is the kind of thing you use Splunk for. So now that I've hopefully stopped the fire from spreading, now I want to analyze this machine and the other machines that are being suspicious and find out what happened so I can understand what the bad guys did and how we can detect their presence. And then you use, for that I'm teaching it in another class. I use Velociraptor. It's probably the main tool here. Velociraptor is an instant response tool that makes it possible to send queries to all the machines in your network to retrieve certain information from them. Like I want the registry keys, I want recently created files, I want a list of your network connections and running processes. You can get all that, or a whole network, harvested back to a central location, and then you can see which machines have this malware. And then you have to get to root cause analysis, and this is where Splunk will really help you. See, once you know you've had an attack, you have to figure out what did they do? And typically, they didn't do just one thing. Something set off something like an antivirus, but they did 5 other things you didn't notice before that. So you have to figure out the whole chain of how they got in. And then you have to plan how to eradicate it by removing all their hooks. They typically have multiple ways to get in. And then you have to figure out what vulnerability let them in and how to close that. So you analyze it for a long period of time, maybe a week, figuring out what happened. And then you plan an eradication event where suddenly you restore all the machines to a clean state and an improved security state so that hole is patched. That's the only way. You kick all the bad guys out and you close the door so they can't get back in. And in order to do that, you have to do root cause analysis. You have to really figure out what they did and how they got in. And that's where you use Splunk for. Analyzing all these logs to find out which server did they hack first, then how did they move to this server, then how did they get privileges on this server, and so on. And it's just like a detective figuring out a crime. You have some evidence and you have some clues and you hunt around looking for more clues to recreate it. And very often you don't succeed. You don't really figure it out. So when you execute your eradication event, they just come right back because they had some more backdoors you didn't find. And that's why, if you're a big company, you don't even try to do it with your staff, you hire Mandiant. Mandiant invented all this. In response to Google intrusion of 2010, when China hacked Google, Mandiant developed modern incident response. And they have textbooks of how to do it, and I'm teaching courses in those textbooks. And so you pay them a pile of money, and they send experts to your company that spend weeks figuring it out. That's what you do if you're a big company and you get hacked. Yeah, they will come in and save you. It's expensive, but you have to do it. It's like an airplane crash. You have these experts figuring out what happened, what to do about it, and it's not something a normal network administrator can do. Thinking you can do it with your own staff is usually your first mistake. Your staff, you really need to be pretty much a security professional to do this. So that's the general picture. And so that's Splunk's role, which I'm glad you're asking. That's what Splunk is for, analyzing in detail what happened here. And we're going to see that. We're going to analyze a bunch of different attacks, and you'll see how you can retrace the bad guys' footprints by using Splunk. And we're going to use these data summary tabs. You can get information like the source, the individual machine that sent up the data, and the type of data that was sent up. Like here's Cisco data from a firewall, here's information from a Linux server, and so on. We'll go through that in detail in the hands-on part later. And here's the place where most people would start. This is the events tab. So I searched for error or fail. And so I'm getting messages that contain the word error or the word fail, and here's the log entries one by one. This is the least efficient, but the simplest way to use Splunk is the way you might use grep. You just search for something and you see the log entries that contain that word. Now the problem is, typically there'll be thousands of them, or millions, so you need to be more picky, but you can see what happened here. So here's failed password for invalid user, failed password for invalid user. So this looks like a brute force attack. Somebody is trying a whole bunch of different usernames to log in here. This looks like, in fact, a password spray attack. The old technique was you'd have one username and you try many passwords, but there's a lot of defenses blocking that. So what they now do is the opposite. They choose one password and use many usernames. And that's what this is. The username keeps changing. Yep, that's right. And so that's what this looks like. And we're going to find those. All right.
Interesting. So it's looking for the human error aspect, assuming that one of us idiots
Use the common
is going
password.
to use something dumb like password 123.
That's right, exactly. And then, so that's right. That's why, like I said, this is a problem with companies. You have to make sure that not even one of your employees is doing the stupid thing, clicking on the link, choosing the bad password, and so
There
on.
must be guys that write programs to pick every single fucking day of the year. Sorry.
Yeah, oh, absolutely. Oh, there's
and
bots.
then use a list of usernames and
Oh,
go by single
yeah.
birthday and assign those as
Oh,
passwords.
this is very common. Most malware will try a bunch of things. In fact, I went to Hope a few years ago, and they had a guy make a Bitcoin account on the cryptocurrency. You know, he made an account, and the key was derived from a password, and he chose a common password. Correct horse battery staple, a famous password from a comic strip. And he showed if you make a Bitcoin account and put money in it and you use a guessable password, within 10 seconds it's stolen. Because people are running bots, trying all the common passwords constantly. And the same thing's true of an SSH server. One of our teachers went home and set up an FTP server for a class demonstration, drove into school. By the time he was here, he'd been hacked.
That's amazing.
Because there's bots. Oh, one of our students did this. He set up a proxy in the lab, and within 5 minutes of setting up the proxy, a bunch of Chinese people started surfing porn through it. Because they were just running bots to scan the whole internet to find services and try the common passwords constantly.
So what are we considering quote unquote common password? Birthdays.
Well, there are famous lists of like the top 100 and the top 10. When I look at malware, it actually has really strange passwords in there. So I guess each developer somehow gets a list. The best thing is to use, what white hats use, is they use big dumps. There's a company, Troy Hunt made a service called Have I Been Pwned, and he is accumulating all the password dumps from everywhere, and he has billions of them. And so that's one place to get them. And in fact, he has a service, which is what you'd use to prevent the scenario you suggested. You can make an agent in your Active Directory, so when people change their password, it will check with Have I Been Pwned, and if you choose a password that has been dumped, it won't let you use it.
I want to do this.
Yep, and that's free available.
So then what you're telling me is every time a hacker gets access to some company's list of passwords,
Yeah.
what they will just do is reassign that to the directory of the bot that they're using to scan the internet.
Well, they might. I mean, each malware developer comes up with a list somewhere. But there are a bunch of known lists from known dumps. And of course, the criminals have private lists.
Sure.
And so they make their own decisions of what they think would be good. Like the name of the company plus 1, 2, 3. There are different theories. And there's a whole thing called PasswordsCon that's part of DEF CON, which is very interesting. I've been there several times. It is very interesting. They discuss all this, and they discuss how to cryptographically protect passwords. And I thought it would be boring, and it is not boring at all. It is the best cryptographers in the world talking about how to deal with these problems. Passwords are very problematic.
What is that thing called again?
PasswordsCon.
PasswordsCon.
Yeah, it's part of B-Sides Las Vegas that takes place during DEF CON.
I was going to say, it's got to be in Vegas.
It's very good. I'm always there.
It was part of what? What was the
Part
other part?
B-Sides Las Vegas.
B-Sides.
Yeah, B-Sides is a convention that takes the same time as DEF CON, but it's free. DEF CON is not free. Or B-Sides is free or cheap. And PasswordsCon is part of it. And it is a bunch of European cryptographers mostly that have got very sophisticated ways to try to protect passwords and choose good passwords and detect breaches. Passwords seem simple. They're not simple at all. Anyway, these are very good questions. So, in this course, the official homework from Splunk is going to use this company called Buttercup Games that sells games, and you're going to be answering normal business questions like how many games sold last month and how many customers still owe us money and stuff like that, not security things. So you're a Splunk Power user, and you're going to do statistics on operations for this because Splunk was trying to market their product for normal business intelligence, not just security. I don't know if that worked. Everybody I know uses it for security. That's why I prefer Boss of the SOC, which we're also going to do in this course, where you analyze real security attacks.
So they wanted it to be just a general...
They wanted to
SQL.
expand their market. So instead of it being a security product, they wanted it to be a business intelligence product where you use it for everything.
Right.
And I don't think that worked. But that was their plan when they designed this certification.
Why don't you think it works?
Because I never hear of anybody using Splunk for anything but security. But I guess I'm not an expert. Maybe it's you. I think there's other BI tools. Microsoft has one. Salesforce has one. I think Splunk did not succeed in becoming a major player in that market.
Okay.
Yeah. But you could use it for that. It's a database. You could do any database function with it in principle.
Well, I just think it's interesting because, as you just say, like databases in principle are all the same.
That's right.
You know, it's
Well, Splunk
rows
has-
and columns of information.
That's right. Well, Splunk has a bunch of features, and the whole community has focused on it as a security tool. So that's been their identity.
Is it because they're doing better at categorizing how the databases are sliced and how you
Yeah.
can get the data more quickly and
Yeah.
visibly?
Yeah, I think it's really branding, right? Everybody writes these agents, and they build it into firewalls and everything. And so everybody thinks of it as security, so it focuses on security. It's hard to, this is why actors don't like it if they play like James Bond, then they're character cast. They have to play that same character forever. Everybody thinks of you that way. It's hard to think about you doing a normal business task.
Except actors like job security is the problem.
Like who?
Actors like job security.
They do. That's one Hopkins. I mean, you make a decision when you get a role like, am I going to accept this being my whole life? because that's what it. And
I
it's just,
think Vin
yeah.
Diesel's pretty happy with the Fast scenario, the Fast franchise.
Yeah. Anyway,
Those
so
dollars.
that's the game of this one. All right, and so we're up to module 2. We can keep going. We've only been a half hour in. So the Splunk components, the 3 main components. You have an indexer, which obviously puts an index to search through the data. The search head does the searching, and the forwarder forwards data from all those remote devices to the central agency. So the indexer processes machine data and gives you the results. So you send in queries, and the indexer searches through this huge index of data and gives you the answers. And one thing that's interesting is the processing time is determined by how many answers you get, which was not obvious. And we'll see that later in the demo. So the search heads, you make a request, the search heads search through all the indexers to find the data and you can also have pretty graphs and stuff, which are good for management. And the forwarders, of course, try to run with minimal resources to forward the logs to the indexer. And as you say, if they run on something like a database server or a DNS server, this might be burdening your server, and so people will complain if you try to log too much data. But the more security conscious you are, the more data you want to log. Yeah.
I assume since the previous slide showed graphs, you can probably set up dashboards that are constantly updating some kind of a slice query
Oh yes.
to give you visual, pretty colors saying
Oh yeah, and that's what the
certain
plugins
users
do.
are doing this, certain users are doing that.
Oh, absolutely. You can make management reports that report the status of things, and management things like how many people haven't paid their bills, how many products are not selling, they're piling up on the shelves, that sort of thing.
Oh, really? So you can actually look at which specific user is using how much of our product, and then we can address whether their invoices are paid and all that.
Yeah,
Interesting.
and you'll do that in the projects. Yeah. All right. So there's also deployment server, which helps you deploy these on more servers. If you have a big network and you decide to have more servers, you can deploy Splunk software from here. And there's something to manage your clusters of servers and all the licenses on a huge network. And these are for huge enterprise class deployments. And I've only heard the names. I've never done any of this. I haven't, and normally a beginner would never touch this. This would be an expert. What beginners will do is use Splunk. Somebody else has set it up and you're going to use it. That's what a security analyst type of job would do, a sort of entry-level job. So this is what we're going to do, a standalone deployment on a single server. Now this is of course not the normal use case. Usually you do it because you have a network of some kind. This is just for training. You put it on one machine and then you practice with that one machine. Obviously, I know tech support people that in fact install Splunk on every machine just to do tech support. They'd like to use it just to search the logs on your one machine. But most people would find that a little crazy. You'd rather just use the built-in Microsoft Event Viewer to view the logs. But you could use Splunk even on one machine. But normally you only do it if you have a network of some kind. That Splunk server, there's the server that does it, and your server serves all these purposes. And
Sorry,
yeah,
I have a question. You
Yeah.
mentioned Windows.
Yeah.
So obviously, Mac's a Linux-based kernel, and you can use terminal to look at logs and things like that on the
Yeah.
machine. So you wouldn't necessarily use Splunk on a Linux-based machine, or
you can. And of course, you do forward all the data from your Linux machines because you have Linux machines in the enterprise. And by the way, like everything else, Splunk runs much better on Linux. Windows is very big and heavy and slow. So if you run Splunk on Windows, you have to give it huge resources, like at least 8 gigabytes of RAM and multiple processors, or it's slow. If you put it on Linux, you can give it 1 gig and it's fine. And the same thing, that's true of almost all software. That's why people like Linux. Linux is much faster and smaller. Windows has all these features that you usually don't need. All right, and so you can have multi-instance where you have multiple indexers, multiple forwards, perhaps even multiple search heads in a big network, but we're not going to do that in the hands-on here. And so there are ways to add more machines to every level of this if you need to handle a lot of data. And all right, and so let's talk about installing Splunk. It is incredibly, what we're going to do is incredibly easy. You just download an installer and run the installer, just like installing any other software, just like a web browser or anything else. And that one Splunk Enterprise installer will install all the components you need. So you download it, you have a Linux version and a Windows version, and you just install it. I'll do it live in a few minutes here. And then you can set it up to monitor the logs on that one machine, or you can set it up to monitor logs on other machines on the network. And so then there's a command line interface. If you want to run it from the command line, you use the command Splunk and you can start and stop, and you can do things like delete data and do other things here. You almost never do that. The GUI is enough to do normal tasks. But if you are having trouble, sometimes you go down and use the command line to figure out what's going on. So after you install Splunk, you have to get data into it. And the simplest way, so you're going to have a forwarder that forwards in data, then it's going to parse it, add up how many megabytes of data you're using to see if you exceed your license, and then index it and put it in the storage. That's what goes on when you ingest data. And so you can connect it to files or directories. Yeah,
Can you go back to the
yeah,
previous-
yeah.
These orange circles, are these to indicate two separate machines? Where you have
No,
source
just separate processes.
Just
So you
separate.
have a source server somewhere, and then it has to parse that data, break the fields up into recognizable fields like IP address and date, and then check your licensing, and then add it to the index.
Right.
Yep, that's what happens. And we're going to have all that going on one machine as separate processes. In an enterprise, they might be separated into different processes to some extent. So you can just connect it to a file and directory and say log the files in here, like the logs file in your Linux server. You can listen to live network data. You can get the output of a script that does any kind of processing. Yeah,
listening to live network data, just to be clear, is requests going back and forth?
yeah. And you choose to listen to like FTP or HTTP or NTP, and it gives you a sort of Cisco NetFlow summary. It doesn't record every packet. It gives you a summary. This request went out, this response came back.
But will it give you a summary of the number of packets that have gone through the node? Or no?
No, but it'll give you the contents of all those packets. So it's
What
not
does
at
that mean?
you'll see it when we get, you'll see like a web request and a web response
Okay, so
without seeing the individual packets.
okay, so you don't know what kind of data is coming through, but
Well, it does listen for certain protocols, and you can configure that.
okay.
Yeah, but it does dissect the protocols and only store like the top level data. It doesn't store every packets like checksum and all that jazz. Wireshark does that, but not Splunk.
And you mentioned the different protocols. You're looking at those sliced individually. You're not looking at them as a group.
That's right. So you have a listener that filters the live data and looks for a certain protocol and indexes that protocol. And you can turn on as many as you want. And you can write scripts to analyze, if you have something proprietary or strange that's not in a standard list of options, you can write scripts to parse the data any way you want.
And just for my clarity and
Yeah.
understanding, those different protocols are generally used by whether the public is just accessing it, whether an administrator or someone with access to the internet network
Typically.
coming from the outside, or a customer maybe.
Yes, however, in modern big networks, it gets complicated. Like, there is not usually one single place where all the traffic goes through.
Right.
Like
so
you
you
have-
have mixed protocols.
Yeah, and you might not get all the data you need from one place. Like you have a network connection, so you'll get all the data going to and from the internet, but you also have internal data between your workstations and your own servers that never passes through there, and you probably want that too. And you might have multiple connections to the internet. You often do for fault tolerance and other reasons, so you probably need multiple taps.
So you
to
have
harvest-
listeners on each of those nodes
Yeah.
looking at each of those protocols.
Yep.
Ugh.
You're going to need all that, or you're going to have bad things happening that you can't see.
Right, because you don't have visibility on it.
Exactly. Yeah. Very good. You can do Windows logs, we're going to do that, and so on. All right. And so every log entry has certain metadata. It has a source, which is some kind of name identifying where it came from, the name of the host, the source type, and an index. You can have indexes of your data to make it easier to search only data. Like you might have an index for every location of your company, so you can more easily search just the data from a location. At big enterprises, this really matters.
Sorry, Sam, I need
Yeah.
to drill down on these. So the source
Yeah.
would be a particular, as you say, input file. So a
Yeah.
computer program, one of those bots we talked about,
Yep.
living in a specific
On a specific server, like
location on a server. So it's
yeah, like one of your
occupying-
web servers.
Right.
That'll be the source, and then you have a name of it. You can have a name, like alphabetical name to help you
Which
remember.
is something that we've created as a person.
Yeah,
Or
like
we have
San
a system
Francisco
that creates
Web 2. Yeah, and then you have the type of data, which is usually a standard type that Splunk understands. It understands like the most common types of data.
So like a text file or whatever.
HTTP or yeah, Windows logs, that sort of thing. Yep, and then you can assign an index to it, with just another way to group it.
Yeah, it's just
For
file
your
location.
convenience. So you can decide how you would like to, because if you search all the data, it's really big and slow.
Yeah, it's too much.
And you probably, most of the time, only want to search for like just the sales data or just the data in one location or something like that. So indexes are how you help group that.
Yep.
Good, very good. All right, so you can add data a lot of ways, and we'll do that. We're just going to import it from simple things. We'll do all that in a few minutes in the hands-on. And so I'll just demonstrate this. You can upload data from a file, you can monitor files, and you can connect to a forwarder that's forwarding data from somewhere like a firewall or something. And so you select a source, and we'll do this hands-on. It's just pretty obvious. Then you set the source type, and you can manually tell it to break the data off into different chunks. But for normal things like Windows logs and Linux logs, there's a predefined source type that will interpret it correctly. And so it automatically determines the source type for common things. You can choose a different one, and you can even make a custom one. If you have some weird thing like a proprietary application that has a weird format, you can write your own indexer to parse it out into the fields. But we're not going to do that. We're going to use standard data. And the pre-trained source types are there for all the usual things like email and operating system logs and so on. And so there's settings here. We'll play with this. That's not worth talking about right now. We'll see it live. And when you're done, you just submit it, and then you'll have some data. Immediately there will be data available. Like I say, you could, in principle, have a cron job that runs every hour, but nobody does that. That's not good enough. It's basically continuous these days. Nobody's willing to wait because everybody has to have up-to-minute information. All right. And so that's all the modules I wanted to talk about today. I'm going to stop the recording of this.